Dear students, today we are discussing about weighted mean. Okay, weighted arithmetic mean. And you know that sometimes we may have different observations in a distribution, and each of the observations may be having some weights according to the importance of the observation. Okay, so we have to assign more or different weights for different observations. Okay, for example, let Wi be the weight attached to the item xi. So then for another example is, suppose you are calculating your index mark for the admission of degree or PG. In that case, we will assign different weights for different subjects. If you are a mathematics student or if you are a science student, suppose you are applying for mathematics course, then the weight for the mathematics will be different from the weights for other subjects. More weight will be assigned to the mathematics mark. Okay, or more weight will be assigned to the science subjects. That means sometimes we have to assign different weights for different observations. Okay, you are admitted as a BSc student based on some index mark. That index mark is calculated based on the mark obtained in different subjects. In Malayalam, you might have obtained some mark in between 0 and 100. In English, you might have obtained some mark in between 0 and 100. And in science subject, you might have obtained different a mark in between 0 and 100. And among the science subjects, you might have obtained mark in mathematics in between 0 and 100. And when we calculate the index mark, we will assign extra weight for mathematics or statistics. Okay, so that is a good example of calculation of different measures using assigning weights. So in this section we are discussing weighted arithmetic mean. Okay, so the formula for calculating the weighted arithmetic mean is given here, equation number 2.5. So weighted, suppose you are given the observations xi, x1, x2, xn, and corresponding weights are wi, I from 1 to 3 etc. n. So weighted arithmetic mean is summation I from 1 to n wi xi divided by wi. Okay, so for example, let me express the weighted arithmetic mean. For the sake of better narration, let me include this values x1, and x1 is having weight w1, x2 is having weight w2, etc. Last, xn is having weight wn. So this is xn wn. So how can we compute the weighted arithmetic mean? Yeah, that is arithmetic mean equal to, what is that? Weighted arithmetic mean equal to, what is that? Let us let me give in this mathematics equation. X1 is the first observation and W1 is the weight associated with first observation. Okay, then X2 is the second observation and W2 is the weight associated with the second observation, and so on. Last, Xn is the nth observation and Wn is the weight associated with the Xn. So how can we compute the weighted arithmetic mean? It's a very simple task. Weighted arithmetic mean equal to, okay, this one is summation I going from 1 to n xi wi, okay, divided by summation I going from 1 to n wi. Okay, is it right? Okay, this is the formula for computing weighted arithmetic mean. For example, we are considering an example, that is, you are getting mark in mathematics 25, you are getting mark in statistics 35, maths statistics, and you are getting mark in, what is that, core subject, that is some 495 out of some 600 or out of some 700, etc. So this is the mark associated with the core courses, and it is especially for mathematics and statistics. When we apply for when we apply for MSc, suppose you are applying for MSc statistics, what we will do, in some institution they will take this mark. This will be all the total mark of core subjects, that is including mathematics and statistics. And if you are applying for statistics, again they will add the mark of statistics. Okay, so this will be the, normally this will be the index mark. Okay, so actually what we are doing, mark in mathematics plus mark in statistics plus mark in physics, this will comprise of core groups, and again we will add mark in statistics. Okay, so here the weight associated with mathematics mark is 1, weight associated with statistics mark is, so we can write like this, 2s plus physics. So weight associated with mathematics mark is 1, weight associated with statistics mark is 2, and weight associated with physics mark is 1. So this is an example of weights, okay, or incorporating weights with calculation of different index numbers. Okay. So the same idea is applied for calculation of arithmetic mean, weighted arithmetic mean. So this is an example, and here we have given the. Okay, sometimes I think we have already studied the mean corresponding to frequency distribution. Okay, you know the formula for calculation of mean of frequency distribution. I think this is the formula for not this one. We have already discussed that for the frequency distribution. Yeah, this is the formula for calculating. Yeah, this one, equation 2.1. So instead of frequencies, we have used weights. Okay, so similar formula we are using in frequency distribution as well as in weighted arithmetic mean calculation. Okay, I think you got the idea. We are giving weights for different observations and calculating the arithmetic mean based on that weight, using that weight. Okay, this is the formula for. So we will consider a typical example and you can understand the concept in detail. Okay, find the simple and the weighted arithmetic mean of the first n natural numbers, the weights being the corresponding numbers. Okay, so we have taken the natural numbers, first n natural numbers. What are the first n natural numbers? 1, 2, 3, etc. n. Okay, at the same time we are considering the weight is what is the weight? Weight is the corresponding number itself. Okay, so weight for observation 1 is 1, weight for observation 2 is 2, weight for observation 3 is 3. So this is a typical example. We can apply this example to different real life situations. Okay, anyway we can study the calculation of weighted arithmetic mean. Okay, same idea can be applied in different contexts. Okay, so what is simple arithmetic mean? Okay, that is 1 plus 2 plus 3 plus etc. n divided by n. So what is the value of 1 plus 2 plus 3 plus etc. n? That is n into n plus 1 by 2. That is a well known formula in mathematics. Okay, now we so what is simple arithmetic mean? X bar is equal to summation I from 1 to n xi by n, that equal 1 plus 2 plus 3 plus etc. n by n, that equal n plus 1 by n plus n into n plus 1 by 2 by n. So I will show that formula here. What is that? Yeah, x bar equal to let us construct like this. This is 1 plus 2 plus etc. plus n by n. So what is the simplified form? We can substitute the value of 1 plus 2 plus, that is n into n plus 1 by 2. Okay, and already we have n. So what will be the result? It is simply n plus 1, sorry, okay, this one, n is get cancelled, so the remaining term is n plus 1 by 2. Okay, so that is the formula given here. So let us put a bar also here. Okay, this is the formula for computing arithmetic mean. Okay, now we move to the calculation of arithmetic, weighted arithmetic. So what is the formula for finding weighted arithmetic mean? So we have to apply the weighted arithmetic mean formula. So what will be the what is the weight associated with each observation? So same number is the same number. Okay. For the observation 1, the weight is 1. For the observation 2, the weight is 2, etc. For the observation n, the weight is n. So what will be the total number? How many number will be there? 1 plus 2 plus etc. plus n. There will be n number of observations. Sorry, 1 plus 2 plus etc. n number of observations. Because for the observation 1, we have 1 observation. For the observation 2, we have 2 observations. For the observation 3, we have 3 observations. For the observation n, we have n observations. Okay. So that is the formula. So what will be the, this is nothing but 1 square plus 2 square plus etc. n square. So what is the value of 1 square plus 2 square plus n square? Yeah, it is given here. That is n into n plus 1 into 2n plus 1 by 6. So we can use that information. That is n into n plus 1 into 2n plus 1 by 6. Okay, so that is the formula. And what is the value of n? That is n into n plus 1 by 2, because we have 1 plus 2 plus etc. n. That is the value is n into n plus 1 by 2. Okay, so we can again simplify. So n plus 1 and n plus 1 will get cancelled, 2 and 6 will be get cancelled and remaining 3. So n and n will get cancelled, so the remaining term will be this one. Okay, am I right? 2n plus 1 by 3. Let us look here. Yeah, they might have. So n plus 1 and 2, 3. Okay, the result is nothing but 2n plus 1 by 3. Okay. I will save it and give you okay, this is the formula. Okay, so this is the concept behind calculation of arithmetic mean, weighted arithmetic mean. I think you got the idea of calculation of weighted arithmetic mean. You can write this matters in your notebook and you can submit through Moodle. Let me look at some documents in Google so that you can use that information also. Google, you can search for the formulas. So
ഒരു മണിക്കൂർ പറയണോ? ഒരു മണിക്കൂർ
This is the, yeah, in this book you can see different problems. Yeah, this one here. Yeah, it's a yeah, we have example 7, you know, look at the example 7. A student obtained 60 mark in statistics, 48 mark in economics, 55 mark in law, 72 mark in commerce, and 45 mark in taxation in an examination. The weights of the marks respectively are, sometimes you can see credits. Credit is actually a weight. You can see that for a statistics there will be some 4 credit for the paper. At the same time, for the mathematics course you may have different weights. Sometimes it may be 5 or 6. Okay, so the weights for the mark respectively are 2, 1, 3, 4 and 2. Calculate simple arithmetic mean and weighted arithmetic mean of the marks. So the mark is displayed here, weight is displayed here. So for the calculation simple arithmetic mean, just add and divide by total number. That is, this is 280 by 5, that is 56. So what is weighted arithmetic mean? So you can multiply this mark with its weight, that is Wx, that is 120, 48, 165, 288, 90, total 711. Okay, that is 59.25. Okay, so this is the weighted arithmetic mean. And in this book you can see some examples. Let us look at the example 6. The average mark of 40 students of class B 38. The average mark of 60 students of another class B is 42. What is this is the example of yesterday's class, last class. What is the average mark of combined group of 100 students? So n1 is given 40, x1 bar 38, n2 equal to 60, x2 bar equal to 42, and combined arithmetic mean is x bar equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. That is calculated here, 40 into 38 plus 60 into 42 divided by 40 plus 60, that equal to 40.4. Okay, and another example, yeah, let us consider all the examples because we have already discussed the arithmetic mean for the frequency distributions for the simple data and weighted arithmetic mean. So in this example, it's a very simple example. Simple arithmetic mean, that is 12, 18, 14, 15 and 16 and added and divided by number, that is 50. Another example is for frequency data. Yeah, the following data indicate daily earnings of 40 workers in a factory. This is the earning 5 rupees, 6 rupees, 7 rupees, 8 rupees and 9 rupees. Number of workers 3 corresponding to 5, 8 corresponding to 6, 12 corresponding to 7 and 10 corresponding to 8 and 7 corresponding to 9. So these are the frequencies. So we can apply the frequency formula, that is total earnings. Yeah, it is somewhat above the margin. So the possible values are 33, 320. Let us calculate from here. What is 5 into 3? That is 15. 6 into 8. No, it is, yeah, it is given here. Okay, it is given here, the last column. Okay, 1548. 1548. 84, 80 and 63. Okay, the total frequency is 40. This is some error in this table. Leave this part, you just use only this part. It's 15, 48, 84, 80, 60. Total is 290. So 290 by 40, that is 7.25. Okay. Another example is given here. Class frequency data 0 to 4, not 04, 0-4. Then 4 to 8, 8 to 12, 12 to 16. The frequencies are given 1, 4, 3 and 2. So we can, since it is a class interval, we can consider the middle values. So what is the middle value? 2. Okay, 2. The middle value for 8 is 6. 8 12 is 10. 12 16 is 14. So we can compute the fx value, that is 2, 24, 30, 28. Total value is taken, that is 84. 84 by capital N, that is 10. 8.4. Okay. This is another example of shortcut method. We have discussed a theory and one example. This is another example. Calculate the arithmetic mean of 305, 320, 332, 350. Okay. Oh, I think the table of this example is merged with the previous example here. Okay. So let us look at this example. What is that? Yeah, it is there. The x observations are 305, 320, 332, 350. There are only 4 observations, and since it is very bigger values, and the multiplication etc. will become too complicated. So to avoid that complication, we subtract 320 from each observation. So what is the difference? Minus 15, 0, 12, 1, 30. So total of D is 27. So what would be the formula for computing mean? X bar equal to A plus, here A is 320. So A plus summation Di by N, that is 320 plus 27 by 4, that is 320 plus 6.75, that is 326.75. Okay, it's a very simple example. Another, we have divided with the constant C. In that case, yeah, D is equal to x minus A by C. In that case, we know that the x bar is equal to A plus summation F by dA by N into C. So how can we calculate arithmetic mean? Consider this class interval data: 0 to 10 3, 10 to 20 12, 20 to 30 20, 30 to 40 10 and 40 to 55. In that case, we take the mid values of the class intervals. What are the mid values? 5, 15, 25, 35, 45. So take the difference. This is x minus 25 by 10, that is, so we obtain the data with the the size of the data are very small, so we can easily deal with this data. Minus 2, minus 1, 0, 1, 2. Compute FD values. So that is minus 6, minus 18, sorry, minus 6, minus 12, 0, 10, 10. Okay, and what is the total value? That is 2. Okay, so just to substitute the values. What is that? X bar equal to A. What is A? A is 25 plus summation FD, that is 2, divided total frequency. What is the total frequency? 50 into C. What is C? 10. we have taken, instead of C we taken 10, so that is substituted here and we get 25.4. so that is the value of arithmetic mean. So you can do this problem also. Okay, so these are the properties. I think we have discussed these properties. Algebraic sum of deviation is this all. I think we have discussed all these properties except the first one. The fourth one is discussed, third one is discussed, second one is discussed. For the first one, you know that I will do that. Suppose the observations are like, what is that? Let us consider. Observations are like y equal to a plus bx. So how can we compute the mean of y? Yeah, you know that mean of y is nothing but, what is y bar? Y bar equal to, actually that is summation I equal to 1 to n yi yn. Okay, so this is the formula of y bar. Okay, so how can we find out this y bar? Yeah, this we can substitute here. Instead of yi we can take a plus b xi, right? Okay, so what will be the next step? You can take the summation a outside, a outside, so we will have only one along with a, and again we can take b outside from the second time, and we will have okay. So this sum is actually instead of this sum, class എടുത്തിട്ട് വാ. Ah. Divide with n. So that is the formula here. Y bar equal to a plus b into x bar. Which is also linear. You can look at the merits and demerits. I think we have already discussed, and you can write down these merits and demerits also. Okay. So up to this you may study up to weighted arithmetic mean, including these examples 7. So you have to write these first 7 examples in your notebook and submit through the Moodle. Okay. I think you got the idea in detail. Okay, thank you.